Hello and welcome to My Security TV and our Tech and Sec Weekly. My name's Chris Cubbage. I'm the Executive Editor with My Security Media. Today we're joined by Tony Scaglieri, or Dr. Tony Scaglieri, who's the Chief Executive Officer with AICRAFT. He's come up with a little device called Pulsar. It's an AI device, and AICRAFT are involved in the purpose-built electronics to craft automated solutions, otherwise known as tailored AI models. So without further ado, Dr. Tony Scaglieri, they're in Adelaide, I believe. Tony, thanks for joining us.
That's right. Good morning, Chris, and pleasure to be with you.
Great. There's various ways we want to go. So we could start with your background. We're going to obviously discuss AICRAFT and your business. And then you've also got a device with you that we'll have a look at. So maybe a little bit about AICRAFT. You're there in Adelaide, and maybe a bit about your background and specialty.
Yeah, sure, absolutely. So I created the company about a year ago now, and
Nice.
that's after spending about 15 years in the defense industry. And I really saw that there is a gap in terms of the hardware that can handle artificial intelligence models. And so I created the company especially to address that gap. It's very difficult when you try to do AI. To find the right compute capacity and the right power level. Usually, it costs you a lot of power, or then you don't have enough compute capacity. So we are trying to fill in the gaps.
And sort of how are you trying to miniaturize high performance computing? What kind of levels are you trying to get to in terms of the computing power?
I mean, we can miniaturize that. Very small. I mean, the size of a matchbox, if you want, and we can still do some of the AI there, and then very low power. Not even a few watts, and that's typically, sometimes there are key power requirements in industry, and these would meet those requirements, which is why now our technology is very advantageous, that we can field it in many applications because it has the right form, it has the right processing capacity, and the thing is, it adds the goodness of doing AI, which gives you that added accuracy with what you're trying to do.
So maybe we can start with the product, and then we can kind of maybe reverse engineer it in terms of how you maybe got there as well. So it's relatively great to see a startup out of Adelaide in this space. Yeah, tell us about Pulsar, and then we can sort of reverse back from there and how you got there.
Yep. So Pulsar really emerged because there's a need to do more calculation on orbit, process more data on orbit. For instance, NASA, there's about 95% of the data that they're collecting which never comes to Earth. And so, that means that, for instance, when they run into a big rock or something, it's too late when they discover that. I mean, these days it's better, but the early probes, or rovers, that's what happened. So we need to really process the data a lot more, sort of faster, and then really transmit the essential sort of informational data, not just data for the sake of it. And that's the problem. There's a lot of data that is generated by the sensors, but not everything is useful. So what our device is doing is actually having the smarts to filter out a lot of that non-informative data, retain what's really needed, and then transmit that.
And just to clarify, you've built this for the space industry as well, or is it for drones and robotics?
Yes, so it has a range of markets. Yes. So the difference with the space industry, I mean, this is, both industries are really needing this type of devices, but especially in space, because you have very stringent power requirements. Even, for instance, the size of satellites these days that are sent, they tend to be very small. Some of them don't have solar panels. And so you're trying to do this advanced analytics, but you have all these constraints that you don't have let's say, the power support. So this is where a device like that is very useful, because it really requires a minimal power consumption, but you can do a lot of processing with it. and we are talking about 10 times what's currently on orbit, for about 30% less power consumption.
Right.
Yeah.
I was going to say, just show us the device and the size, and we'll have some overlay pictures of this as well. And I think you have an iPhone 11 just to show the scale.
Yeah. So that's the size comparison. So
it's probably around the same weight, is it?
Yeah, that's right. Yeah, very much so. Probably about maybe twice the weight of the iPhone.
Okay.
Just with the heatsink on top. But basically, this plugs in the satellite. So with the pins there, that's how we get the power. And then we've got very fast connection, sort of. I don't know if we see, but through there. So that's where the data will come from. But yeah, very small. So if I can really put them together. So that's the device, just like that, and then from the side.
And where did you start from? So that's been manufactured here in Australia, is it?
Yes, absolutely. So everything's manufactured here in Australia, which was one of my key sort of requirement that I wanted to do. I love the idea of, in the same way you go to the supermarket to do your groceries, you just come here and you just, you have everything produced here. It's much faster. You have everything available. So
is it 3D printed?
So this is the model is 3D printed. There are parts that are 3D printed, but otherwise it's sort of a different material for the casing. Yeah.
Because I was going to ask, can you change the format of that in terms of its shape? So there's always that issue on robotics, and particularly on drones, and is the size and weight of the payload and how it might fit on the aircraft. So can you change the form factor?
Yeah, absolutely. So in this case, it's actually 10 by 10 centimeters to fit exactly in a CubeSat. So basically, they are like Lego sets, and so they have this type of form factor. But yes, that's the good thing with what we do. We design here, we manufacture here. So if someone wants something a different form, then we engineer to those specifications, and that's where we're having the conversation with our customers that we really integrate with their systems. We make it fit.
Yeah. And where did you start? What's your starting point on that? Is it the power? Like what's the priorities in terms of delivery? So is it reduce power loads and then processing, or was it the processing first and then trying to reduce the power? What was your focus?
I think the processing is more the key part at this stage, because, for instance, that might mean that if you're able to reduce the data volume, you might be able to, let's say, have more customers for the same transmission when you're broadcasting. You might be able to process, for instance, Earth observation data without, for instance, if you're looking for icebergs and you're flying over a continent, well, you don't necessarily need to send that data because there's nothing that you're interested in. So the processing is really the key aspect there. And of course, I mean, when you're on a satellite or even a mobile platform, the power is also important, which is also where we're working. But a lot of the time, that's sort of secondary.
Okay. And what's your processing power? What would be a good comparison to what you're actually achieving? And is it an operating system, or you just upload whatever software you need?
Yeah, that's correct. So this is very flexible, actually. Any graduate from university would be able to program this. It doesn't require any specialized skills. We've got a software interface that lets you basically install the libraries that you want. So it's very straightforward. And then, in terms of the data volume, I mean, you're talking, half a terabyte in 10 minutes. So to give you some ideas, it basically, 10 to 50 gigabyte, which is a lot of data. We spend only a handful of seconds to do that.
Nice. And did you build this to spec, or have you just created this and then now go out finding the market? Was it built for a client, or you obviously you have involvement with CubeSats, do you, that you knew what the requirements?
It was I think so it was with an understanding of the domain and what's needed, and of course understanding what the customers and the clients now are looking for. And so we made sort of design our own specifications, but with a lot of experience in the background to build it.
Okay, and so what's the go-to market, and a little bit about the business as well? AICRAFT, are you backed by investors, and what's the go-to market approach now?
Yep. So far, we've managed actually with direct contracts from clients,
Right.
and then some self-funded money. But otherwise, yeah, the market is really, there's a lot of new constellations that are constantly being launched. So this is where we are targeting. I mean, you're talking for the small, the CubeSat market. It's over 300 satellites a year. We are meeting the form factor and the power requirements with the added computing capacity. But there's also large constellations that are in progress, and we're involved with large national programs. For instance, the Bureau of Meteorology, Geoscience Australia. They are looking to build a large satellite for Earth observation. They want, for instance, 30-minute turnaround for some of their weather prediction. And at the moment, this is not possible. However, with a device like this, we can certainly handle that volume of data. So that's the kind of new enabler that we're bringing to the market. And so we are talking now with the large satellite companies to then integrate our technology and be part of those government contracts.
Is there something you can piggyback on other satellites and receive data to crunch it for other clients? So you can just be sat there and retrieve data from other sort of satellite services and crunch their data for them? Or do you have to be on the actual satellite receiving the data? What's the communications and data transmission process?
Yeah, so I think on that side, so there are now very capable transmission systems. So we can think of sending the data across space, and then for our device to then process that. That might cost in terms of the power, because transmission is very demanding in terms of the power consumption. Again, this is one of the trade-off we're examining right now, about how is it best to share the data once you've sort of packaged it up or reduced it. So it is an optimization, but it is a possible model, and especially our goal is to be able to do this federated learning or distributed learning among a constellation of satellites. So that's exactly the idea that you brought forward now.
And it's something that's on your website in terms of you are looking at the edge computing. So this is obviously doing the processing at the edge before the data is sent, and you're saving a lot of, that's really one of the solutions, isn't it? You're saving a lot on that data transmission. You might be gathering all of that data and sort of gigabytes and terabytes of data in space or on the device, but you can crunch it before you send it. And so you're only sending the relevant or processed data, right?
Yes, absolutely. And that's where there's a trade-off. The sensors these days are very accurate. The downside is that it takes a lot of footprint, a lot of memory. And therefore, that's where we are acting, is that we are trying to still retain the accuracy, but reduce the data footprint, so that then you have very accurate information and intelligence that you extract. And we do that even before the data gets to the processor or anything like that. So filtering right at the start.
Do you understand, or how do you verify the data coming back? Because you can't access the device once it's on a CubeSat. So how do you verify the data coming through that it's accurate? How do you interrogate? Can you access the device remotely?
Yes.
And adapt it?
Yeah, absolutely. So the thing is, the device is fully programmable remotely. So we gather the data, we can downlink the data to Earth, have more computing resources to improve the models, and then upload the models back on the satellite. Yeah. So that's one model. But in terms of validating, again, it's part of the mission profile where in some instances we would just purely collect the whole of the data and then downlink that. This is what's currently being done. So we're not changing anything there. And then that enables you to do, for instance, cloud computing here on the ground and improve those models and then uplink those models again. But then at the same time, there are operational needs where you need to process the data live. And that's where after we can do that processing sort of right on board, or even teaching the AI models live as you collect the data. So one of our mission objective is to try to train in one orbit, which means that, let's say you see you've got a camera and you see something of interest and you don't know what it is, but then you train your AI model to recognize that the next time around. So you might not know what it is, but you can recognize that it's the same unknown. Yep. Instead of labeling everything as unknown, you already categorize that. And then that's the information that then you can pass on to an operator, and the operator will see 10 thumbnails of the same thing that your AI model would have already picked out of terabytes of data. So that's the real value. And then the operator can put a label onto it, so that's where, we are facilitating those tasks.
I was going to ask, is there a particular data sets that it's strongest in? You mentioned computer vision. It's a video, and obviously that's high data rates for video.
Absolutely.
Or otherwise just sort of communications, radio frequencies, and the others.
Yeah. So
is there any data sets that it's strongest in?
I mean, it all comes down after. I wouldn't say that there is a particular strength, because I think that's the value of the device, is that it's applicable to any type of data.
It's a processor at the end of the day, is that right?
Yeah, then it becomes just a software task where you've got your software that knows how to analyze the data from your sensor.
Yeah. Is it like a really, really powerful mini workstation? Is that what it is?
Yeah, absolutely. Like a mini workstation, a mini server. Everything's on there. We pack all the electronics. And so, you can equally look at signal data, like radio data. You can look at, for instance, synthetic aperture radar. That's used a lot, for instance, to look at gas emissions, for instance, like CO2 emissions. Also, for instance, if there's water leaks, you can detect water leaks in cities from space.
Okay.
So that's the kind of thing that this enables. That sometimes you can't, when you're on the ground, you actually can't see those things or can't detect easily.
Well, we've done a number of, I'll say Jane, our Singapore correspondent, has done a number of high performance computing interviews, and she did one with Oak Ridge National Laboratory for the first exascale supercomputer, which I think was equivalent to like 100 PlayStations going at anyone simultaneously together, with the latest PlayStation, that is. Do you know what your sort of scale is here? And you mentioned you can crunch the numbers, but what in a high performance computing ratio, where are you? And is that the innovation? You've shrunk this down. Where's the key innovation for you in this?
Yeah, that's right. I think it's it's being able to miniaturize the ability to crunch a lot of data.
Are you in HPC level? Are you at a HPC level?
Not for this size of devices.
Okay,
we do have graphic cards, and we do have servers that leverages from the same chipset. But that's,
is it off the shelf, Tony? Sorry, is it off the shelf stuff?
Not exactly. It's highly specialized, and that's what we supply after to the market. So
And have you got some patents out of it?
There are some patents. Yes. Again, that's through partnerships that we've got. Yeah.
Nice. And we'll welcome you to sort of highlight any other partners. Is there any Because I take it it's not just Tony Scaliri just doing it on his own. I take it you've got partners there along the way. Is there anyone you wanted to recognise or highlight in terms of the importance of partnerships?
I think at this stage it's still sensitive for us to announce the partnerships, and some of them, I must say, they are secret partnerships. There's a lot of things to. I mean, it's extremely sensitive technology, and therefore we are very cautious, especially with all the cyber attacks and all of this. So we want to maximize the protection there. But look, the partnerships either they are with semiconductor companies, so anybody. Well, not anybody, but those that are involved in manufacturing processes, some of the very advanced AI chipset, and so also the, for instance, some microelectronics. And so we have a partnership now. For instance, we need a small component, but it needs to go 10 times faster to handle the speed at which a device is going. So we are going to have a collaboration there to build these new small components. Nice. And that's the type of thing that then we are projecting that would sell by the millions.
So you're definitely more on the hardware side. Something that came out of that interview I just referred to with Jane is the software needs to get a bit smarter too, because we're getting to the limits of what the hardware can do. But there's a lot of work that we can still do to improve software efficiency and efficacy. Yes. Are you observing that as well?
Yes, absolutely. And our work is exactly a combination of the two. But it comes with a very deep understanding of data and analytics in general. Yeah. And we build better hardware to better support that. So that's why really the emphasis is a lot on the hardware to be able to cope with what the software requires to really get that analysis, and at the same time, managing better the let's say the load that the software will require to perform at its best. So
very good. Well, look, I suppose I've got about 100 other questions. I like that it's a bit sensitive too, because that keeps the audience interested, and it's one to watch now in terms of AICRAFT. Any particular call to action, or are you just looking to get a bit of branding out there and awareness out there, or do you have a specific call to action at this stage?
Look, I mean, we are going to production, and so we'll be advertising soon for let's say the desktop version of this space module. Nice. And that's something that will have the same form factor, but then a lot more. While this is specialized for plugging in a satellite, the other one will have, for instance, lots of USB ports. Still a fast Ethernet connection. So really something that will be a plug and play for people, but it will retain all the goodness in terms of the power efficiency and the crunch, compute capacity. Nice.
I imagine it's an AI device that you can start to play with before you even stick it up in space. But it can just be an AI piece of hardware for you to. And just to clarify again, so it's clear with me, you upload your own AI software, or it comes with AI software? Is it just the power and the processing?
Yeah, both. So the thing is, we will make our software libraries available, right. and then we also it's also for customers to develop their own. So they'll be able to install everything and do their own development, which is what we want to facilitate. And at the end of the day, they'll just buy the hardware and then they'll be able to prototype everything. And again, sometimes, I mean, everything is sensitive. So, customers want to have the ability to develop their own software and then deploy it on a target hardware. So that's what we will enable. And at this stage, of course, we are working closely with customers to meet their requirements. But then, like I said, now we're going to market to really enable more people to do more. So whether it's I've got customers, for instance, for drones, robots on the ground. They've got, for instance, very good cameras or antennas, but they need their computing support is already struggling with the amount of data. So if we put something in between, which doesn't cost you that much power, but which gives you that added analytics. That's what they are looking for.
Right. The go-to market, how are the customers going to get to you, and do you have a price range for this as well?
Yes, so we're trying to be competitive with some of the other solutions out there, although we have quite clear differentiators. But at the moment, we are working with integrators. So either people that they can do some of the engineering that will deliver a whole system. So if it's an autonomous system, then it'll be embedded in there. But also, for instance, academics and hobbyists that can just take the device and plug it into their remote controlled toy, and here you go, do something fancy with it.
So it's effectively just going to be available on your website. They can just order it from you.
Yes, that's right. So we are going to update that very soon and put the devices there. We're going to have flyers with an exact description of the specs, and then people can can just work there and basically put some order through. We would like this to be available in the next couple of months.
Right.
Yep.
Well, look, hence doing the interview with you. Thank you for reaching out to us, and also best of luck. It's always great to see an Australian startup, an Australian manufacturer of advanced technology. So well done to Dr. Tony Scalieri, Chief Executive Officer with AICRAFT in Adelaide. Thanks very much for joining us on MySec TV.
Thank you very much for having me. It's been a pleasure. So,
good man.
Thank you.
Thank you.